3.1 for the independent sample, and then you will have 3.3.2 for the dependent sample. Okay, so both will be in your quiz 3 lah. Okay, so your section will be on Monday 12 p.m. Okay, so I think that's all regarding the task and also the quizzes. Okay, so later in the day you can check lah in your IMS, okay, the mark. Okay, I think it will be today lah, because I have to send the the report of your test by today. Okay, so later you can check. Okay, so we go to the lesson for this week. So it should be you should study about 3.8 until 4.2 lah for this week. Okay, so just a summarization, okay, for the topic for this week. Okay, so 3.8 we have the so far anything that you want to ask regarding the quiz and also the task? No, okay. So we go to the 3.8 hypothesis testing using confidence interval approach. So the one that we discussed before this, there are traditional approach. Okay, traditional approach. So at the beginning of this chapter, I have explained that we have 3 different methods to conduct the hypothesis testing. Okay, the first one we have the traditional approach, and then we have the confidence interval approach, and then we have the p-value approach. Okay, so the application of the p-value, it is in your assignment part 2. So after today, you should preparing for your assignment part 2 lah, and then submit I think a week or 2 weeks after this week lah. Okay, so how to submit similar as what we did for the part 1, you just email to my email lah. Okay, so p-value approach, okay, the application of the p-value approach, it will be until we go to the chapter 6. Okay, in chapter 4 later you will find the p-value, chapter 5 the p-value. In chapter 6, we also have the application of the p-value, okay? Especially, we will use a lot p-value, especially when we go to the chapter 5, okay? So, chapter 5 later, okay? Just an introduction, okay? You have the simple linear regression and also you have the multiple linear regression, okay? For the simple linear regression, we do calculate some of the value manually, but for the multiple linear regression, everything, okay, we use Microsoft Excel. We do not calculate manually for the multiple linear regression. So once you have the output from Microsoft Excel, then we will go to the p-value approach, okay, for the hypothesis testing for the chapter 5. Okay, so this p-value approach will be until the end of this course, okay? So first we go to the confidence interval approach, okay? So confidence interval approach only for the two-tail case, okay? So we know that, okay, when we discuss the traditional approach, we have the one-tail case, okay? And then we have the two-tail case, okay? So the confidence interval approach only for the case two tail. We cannot use when we have left tail. We cannot use when we have the right tail. So only for the two tail case. Okay, why only for the two tail case? Because of the what we call the idea of the confidence interval itself. Okay, because of we have two-sided. Even though we calculate for the one-sided lower bound or upper bound, at the end when we write the answer, we have to write both sides. Okay, so still we have two-sided. Okay, so because of the idea of the confidence interval, we have A and B. It is similar when we have two-tail case. Okay, so similar idea. So that's why the confidence interval only for the case two-tail case. Okay, so the procedure similar to the confidence interval. Okay, we still have the start 1, okay, the hypothesis. So the hypothesis here must be two-tail only, okay. So theta represent parameter and theta naught represent the value, okay. So In traditional approach, the step 2 is to calculate the task statistic, but for the confidence interval approach, the step 2 is to calculate the confidence interval. Okay, so the confidence interval here, the formula will be in chapter 2. Okay, will be in chapter 2. So depends on what parameter that we have in hypothesis testing. So let's say that the hypothesis is about mean. So the confidence interval will be about the mean also lah. Okay, if you have mu, only mu, then refer to the confidence interval for the mu. Okay, if you have mu1 and mu2, so refer to the confidence interval of mu1 and mu2. So that's how chapter 2 and chapter 3 related to each other lah. Okay, so step 3, okay. So because of we have what we call confidence interval approach, we do not use the critical value. So step 3, we jump to the decision. Okay, comparison and decision. Okay. So what we compare for the confidence interval approach? Okay. Step 1, hypothesis. Step 2, you will get your confidence interval. So A and B here. Okay. So step 3, decision. So what we do for the confidence interval, we compare the confidence interval that you get in step 2 versus theta node. Okay, versus theta node. So theta node here, okay, theta node here, it is from your step 1. Okay, the population value. So if you have mu as your parameter, then theta node here is your mu node lah. If you have pi as your parameter, then theta node here, it is a pi node. Okay, so if you have variance as your parameter, then here will be theta node square. Okay, so we compare the population value from hypothesis with the what we call here confidence interval. Okay, so if, okay, I will show in this figure. Okay, when we compare, if your theta node somewhere in between, here for example, so means that do not reject H0. Okay, again, please do not write accept H0. I found in your task you wrote the accept H0, but still I give mark lah. Okay, so next time, okay, do not reject the accept. Do not write as a accept H0. It is do not reject H0. Okay, it is I know that it is a similar meaning, but in mathematical writing it is wrong lah to write the accept H0. So if your theta node here, okay, included, okay, then do not reject H0. So similar if we are, so the idea is similar as when we have the two-tailed case. Okay, if it is in between, then do not reject. So if your theta node, okay, outside from the A, outside from the B, for example that it is somewhere here or here, then reject H0. So if theta node is not included in A and B, then reject H0. Okay, so that's the difference with the traditional approach. Then step 4, just a conclusion. So step 4, similar. In our conclusion, we discuss the claim. Okay, we discuss the claim. And again, decision here, okay, based on your task, okay. The decision here, so that you not repeat similar mistake. The decision here, we just write what happened to the H0, whether reject H0 or whether you do not reject H0. Okay, what happened to the H0, not the H1, because I found some of the students, they wrote what happened to the H1. Okay, I know that when we reject H0 means that we do not reject H1, but Is this not right lah? Okay, decision, we write what happened to Dashna because when we formulate the hypothesis, we assume that Hashna is always true. Okay, when we formulate the hypothesis, we always assume that Hashna is true. So that's why in our decision, we have to talk what happened to the Hashna, not the H1. Okay. So any question regarding the procedure? No? Okay. You can hear me, right?
Yes, madam.
Okay. Okay, so this is confident interval approach. We go straight to the p-value approach so that you can see the difference between them. Okay, so p-value approach. Okay, so p-value approach, it is for all type of hypothesis. Okay, it is for the one tail and also two tail. Okay, so the difference between one tail and two tail, it is on your p-value lah, because when we, okay, whenever we ask you to do the p-value approach, it will be given in your question. Okay, what's given in your question? The output from Microsoft Excel, and then you read from the output which one is your p-value. So usually in our output we have two types, or we have two values that represent p-value. The first p-value, it is for the one tail case, and the second p-value for the case two tail. So it is depends on your hypothesis. Okay, whether you have one tail or whether you have two tail. So one tail here means that you have right or left tail. Okay, and then you read the p-value that related to that. Okay, one tail or two tails. That's the only difference. Okay, we never ask about p-value without the output. We never ask you to calculate manually. I found in your test, some of you use the p-value. Okay, I don't know how you get the p-value, and definitely it is a prohibited lah, because in our declaration form, we already state that you only can refer to your module, slide, and also the videos that we have, that we provide to you, and also the statistical table. So you are not allowed to use the Microsoft Excel. The only way to get the p-value is by using software lah. It is by using software, Microsoft Excel or any software that you can find regarding the related to the statistical. Okay, so whoever use p-value, definitely you get 0. Okay, so absolutely wrong lah. Okay, absolutely wrong. Okay, and in fact, if this is not the open book test, you never know yet about the p-value approach, because we already state that the material is from 3.2 only. Okay, so be wise lah bila you buat all this thing. Okay, and one thing that I want to about your task. Okay, the critical value. Okay, some of you did round up the critical value. Okay, I never teach you to round up the critical value. Okay, so critical value, I hope I think that you should be understand what is critical value, the Z alpha, the T alpha, okay, the T distribution, the Z distribution, chi-square, and also the F. Okay. Whenever you write, whenever you need to find the critical value, okay, the only way that we use for this course is by refer to the statistical table. Okay, only assignment we ask you to do by using Microsoft Excel, only the assignment. The rest of it, okay, tasks, quizzes, and also final, okay, you have to use the statistical table. Okay, so the critical value, when you write your critical value, use as what you get in statistical table. Do not ever round up the value. Okay, some of you round up, I cannot accept that, then you will get 0 lah for the critical value, even though it is, the value is close lah. For example, that you have 16449. Okay, the Z alpha over 2, you get 16449. Okay, most of you round up this one. Okay, I don't like that. Okay, when you find the critical value in statistical table, use as it is in statistical table. Do not round up. I cannot accept this one. If you round out, your answer means that, let's say that you round up the confidence interval, I can accept that one. Okay, because it's just a decimal places. But this critical value, no. Okay, you have to use similar value that you get from the statistical table. Okay, if you use this, there's only two possibility. First one, you round up the value. The second one, you use another one. I mean, you use another method to get the critical value. Okay, I noticed that some of you write the code to get the critical value. The R code, I don't know whether you use the R programming or what, but based on the code, it is a R programming. Okay, so it is not allowed to use, okay, for the task. Okay, so be careful when you do the quizzes and also final letter. Do not round up the value that you get from statistical table. It is what we call a waste to lose 1 mark because of that. Okay, okay, we back to the value here. Okay, so just so that you not repeat similar mistake for the next of the assessment. Okay, so the p-value approach, the first step is similar. We state what is our H0 and also what is our H1, similar. Okay, and the step 2 is to get your p-value. So to get the p-value, it is not you have to calculate manually. Okay, so p-value in step 2 means that we read from the output. Okay, the step 2 here, it is not to calculate manually. Okay, it meant that you have to read from the output from Microsoft Excel. Okay, in final, if you have the p-value approach, we give you the output, we provide you with the output. Okay, okay, so after that, step 3 is decision. Okay, so the p-value here, the value that we compare for the decision is a p-value itself versus alpha only. Okay, versus alpha. Okay, the alpha here doesn't matter if you have the two-tail case, we do not divide by 2. Okay, it's just alpha. Okay, doesn't matter you have the two-tail case, we do not divide alpha by 2. It's just alpha. Okay, so for the decision here, p-value compare with the alpha. Whenever your p-value, okay, for the p-value here, we do not what we call the decision here, it is not based on the type of your hypothesis. Okay, your traditional approach, it is based on the type of your hypothesis. Okay, but the p-value here, whenever your p-value less and equal to the alpha, it always reject H0. That's it. It doesn't matter you have one tail, doesn't matter you have two tail. It doesn't matter you have right tail, or doesn't matter that you have left tail. And even though we have two-tail case, the alpha not to divide by 2. It's just alpha. Okay, the alpha that we divide by 2, it is for the traditional approach. Okay. So the second one, whenever your p-value greater than alpha, then do not reject H0. Okay. So step 4, conclusion as usual. Okay, we discuss what happened to the claim. Discuss the claim. Any questions so far? No? Okay.
Madam.
Okay, so in conclusion, the difference between the three methods for the hypothesis testing. Okay, so the conclusion here. So we have three methods. We have traditional approach, we have the confidence interval, and we have the p-value. Okay, so the difference between those three methods, it is on your decision. Okay, so traditional here, we compare the test statistic versus critical value. Okay, CI here, we compare the confidence interval okay, versus theta node. And p-value here, we compare the p-value versus alpha. Okay, so that's the difference between those three methods for the hypothesis testing. Okay, so let's say that we have similar problem. Okay, the problem. Okay, we have similar problem. Okay, doesn't matter what method that you use to solve this problem. Okay, you will come up with similar decision and conclusion. Okay, you can check by your own that one. Okay, doesn't matter what method that you use, if we have similar problem, you will come out with similar decision and conclusion. Okay, similar. Okay, the hypothesis also similar. So means that decision, conclusion, and the hypothesis will be similar for all these uh, method. If you get reject, then all must be reject hash not. If you get do not reject, and all must be do not reject hash not. Okay, because of we have similar problem. Okay. Okay, so that's the conclusion of the method for the hypothesis testing. Okay, we go to the exercise 3.8 for the confidence interval approach. Okay, for the p-value approach, are we not discussing any exercise? That one you can practice in your assignment. Okay, so how to get the p-value? Okay, for the mu, for the variance, you can refer to the videos that we upload lah. Okay, and watch that videos and then do your assignment. Okay, and also you can refer to the step in your module. Okay, and also we have step in our slide here, so you can always refer to that lah. Okay, so the part of the p-value approach, I leave it to you. Okay, you study your own that one. Okay, watch the video, refer the note, and then do your assignment. Okay. Okay, we go to the 3.8 here. So first we need to extract the information. Okay, based on the past record of the pharmaceutical company, the cure rate for a standard medication in treating a particular ailment is 10%. What is 10% here? Okay, baca dulu and then I ask you in 2 minutes. Okay, I need to know what is the variable. Okay, you can read first. What is the variable? Anyone? Anyone? Variable?
Cure rate of the standard medication.
Cure rate. Okay, so the variable here is a cure rate. Okay, so the cure rate for a standard medication is 10%. Okay, whenever you have percentage of something, automatically it is proportional. Okay, it is proportion. Okay, so 10%, pi or p? 10%, pi or p? Agak-agak? Tak boleh agak-agak dah, you have to know exactly like sini. Pi or p? 10%. It is? It is a pi because of past record. Okay, past record. So we have discussed that anything from the past record, past study, old method, it is a proportion. It is a population. Okay, so we have pi for the standard medication here. So here we have standard medication and also the new medication. So you can divide by 2 like this. Okay, so we have standard and then we have the new medication. So what we have? So first we have pi. Whenever you write pi, so it must be in what we call probability lah. So 10%, 0.1. Okay, in a simple random sample of the 200 subject who took the new medication, it is found that 60 subjects are uncured. Okay, so 200 here, what is that? N. So N for the new medication. So you can write here N equal to 200. It was found that 60 subjects are uncured. So what does it mean? What is 60 here? Sixty tu apa? Y. Oh, okay, you can use Y. Y is a what? Number of failure because here is a cure rate. So uncured failure lah. Okay. So 60 it is a number of failure. So from 200 means that 140 cure lah. Okay, so you can write here X 140. Okay. Meanwhile, 180 subjects are completely cured from 300 subjects who took the standard medication. So 180, apa? What is that? X for the standard medication. 300? It is? 10. Okay, given that 97.8% confidence interval for the cure rate of standard medication is. So here we have the confidence interval for the cure rate of standard medication. So you can write here. We continue here, right? So you have 79.8% confidence interval, 0.5352 and 0.6648. Okay, for the standard medication. Can we conclude that the cure rates of the standard medication do not change from past record? So this is what we call the purpose of this question. So this is your hypothesis. Okay, so given that confidence interval, can we conclude? So means that you have to conclude this based on the confidence interval. Okay, so you have to use the confidence interval approach. You cannot use the traditional approach. Okay, because in this question specifically, Okay, dia memang nak kita pakai confident interval. So given that confident interval, can we conclude that? So what you have to conclude here, the conclusion here must be based on confident interval. So it is confident interval approach. Even though you have all the informations that you need for the traditional approach, you cannot use traditional approach. Okay, you have to use the confident interval approach. Okay, for this conclusion. So letter in final letter, if you have this kind of question, it will be mentioned in that question that you have to use the confident interval approach. Okay, specifically. Kalau tak mention macam kita buat sebelum-belum ni, dia tak ada mention what method that you have to use. So actually you can you can decide by your own whether you want to use the traditional approach or whether you want to use the confident interval if you have the two tail case, and kalau you ada output from Microsoft Excel, you can use the p-value approach. So if didn't mention in your question what method that you have to use, that is up to you. You want to use which method? Okay, traditional, confident interval, p-value, but for the p-value, you need to have the output from Microsoft Excel in that question. Okay, kita memang, you are not going to find your own p-value lah, especially for the final and quizzes. Okay, except the assignment. Assignment, you have to find your own p-value. Okay, so the first step here, hypothesis. So we know that it is a confident interval approach. So memang tak boleh pakai another approach. So step 1. Can we conclude that the cure rate of the standard medication do not change from the past record? Okay, so we already know it is a pi, okay, because what we have here is a proportion. Do not change, what kind of sign for the do not change? It is equal from the past record. Okay, so then refer back to your past record. Okay, the cure rate of the standard medication is 10%. So 10% here, it is your pi note. Okay, so you wrote here equal H0 or H1. H0 or H1. H0 or H1?
H0.
So H1 opposite to that, pi not equal to the 0.1. Where is your claim? Hey, where is your claim? Claim kat mana? H0. Step 2, for the confident interval approach, we need to calculate the confident interval. But in this case, you already given the confident interval. So use as it is. So we have 97.8, and then this is your confident interval. So what we have, 97.8% CI. Okay, so we have 0. And then we have, okay. So step 3, decision. So we compare pi note with the confident interval. Reject or do not reject? Reject or do not reject? We already discussed how to make a decision here. So reject or do not reject?
Reject.
Reject Hashna. Okay. So if you want to sketch, then sketch. This is your lower bound of confidence interval 0.5352, and this is the upper bound of your confidence interval 0.6648. Okay, and then we have to compare with the pi note. So you can sketch, you can plot where is your pi note. So pi note 0.1, it is somewhere here. So outside from the interval, then reject H now. So you can write here since pi note 0.1 is not included in interval. So reject H now. What happened to the claim? Do we support the claim? No. Okay. So at alpha, what alpha here? What is your alpha here? What is your alpha here? What is your alpha? 0.022. So your alpha based on the confidence interval that we have here. Okay. Tak boleh pakai another alpha lah. Kalau you nak pakai another alpha, then you have to construct another confidence interval. So at alpha 0.022, medication. Any question? Okay. Any question? Tak ada?
Tak ada.
Okay. So I have explained about the p-value approach. Okay. So this one is on you. Okay. So you can refer to this note or you can watch the video how to get the p-value from Microsoft Excel. We have all the steps here that you can use to get your p-value from Microsoft Excel. Okay. Then prepare for your assignment part 2. Okay. So the next one, we go to the last subtopic for chapter 3. We have the type of errors. Okay. For the hypothesis testing, we have 2 errors that we discussed. The first one type 1 and the second one type 2. Okay. So type 1 error is an error of rejecting the null hypothesis when it is a true. Okay, denoted by the alpha. Okay, the notation that we use. Okay, and then the second error is a type 2 error. It's an error of failing to reject the null hypothesis when it is a false. Okay, and here is a possible outcome and type of error. Okay. We make a summary here and then we do sekejap Okay, sorry for that. Okay, so we try to identify the error based on the exercise that we do just now. Jauh pula dia. Okay, this one. Okay, first error. Okay, so we know that we have two type of error. The first one, type 1. Okay, so type 1 error, it is a probability of reject hash null when hash null is true. Hash null is true. Type 2 error is probability of do not reject hash null when hash null is false. Okay, so the condition of hash null is true or false. Okay, in order for us to identify this error, first you have to know whether your hash null is true or false. Okay, so the condition is hash null is true or false depends on the first one, condition in population. Okay, condition in population means that, okay, in that question, you are given the condition of population. Means that, for example, okay, and the condition in that population refer to what? Whether you're hash null or hash 1. Okay, whether you're hash null or hash 1. Okay, that's how we determine. Okay, if that condition refer to the hash null, means that hash null is true. Okay, if that condition refer to the hash 1, so means that hash 1 is means that hash 1 is true, so means that hash null is false. Okay, so the first one depends on the condition in the population. Okay, sometimes you are given, okay, condition in population, and then we determine that condition refer to what? Hash null or hash 1. So if refer to hash null, so means that hash null is true. If refer to the hash 1, so means that hash null is false. Okay, refer to that. Okay, let's say that there is no condition in population given in your question. Okay, then how we determine hash null is true or false? It is depends on the claim. Okay, it is depends on the claim. Okay, depend on the claim. And in fact, okay, the claim is actually about the population. Okay, the claim that we do, the claim that we made in our hypothesis, it is about the population. Okay, so that's why we can determine the condition of the hash null here based on the claim. Okay, so kalau if your claim at hash null means that hash null is true. If your claim at hash 1 means that hash null is false. Okay, this condition it is for hash null, not for the hash 1. Okay, that's why we need to decide hash null is true or false. Okay, after we know hash null is true or false, then the second thing that we need is a decision. Based on your hypothesis, whether you reject hash null or whether you do not reject hash null. Okay, then we can determine what error that we have. Okay, other than these two error, you also can get another condition. Okay, let's say that we have reject hash null when hash null is false. What we have here, what error that we have here? Reject hash null when hash null is false. What is possible error that we can get here? Anyone? no error. We reject hash now when it is false, so no error. No error, or you can write correct decision. So when you have the questions about the error, it is not necessary that you will get type 1 or type 2. Sometimes you will get no error. Also the error lah, okay? No error or correct decision. So don't be panic if you have no error because it is correct. Okay, because you reject Ashna is false. So correct decision to make, so no error. Or you will have this condition, do not reject Hashna when Hashna is true. When Hashna is true. So also correct decision. Hashna is true and do not reject Hashna. So correct decision to make. So no error. So there is a 3 possible what we call error lah that you can get. Type 1 error, type 2 error, or it is no error. Okay. Any questions so far? No? Okay. We go back to this exercise. Okay, based on this exercise, your Hashna is true or false? Let's say that the next question is to identify the error. Yeah, identify the error. So first we need to know condition of Hashna. So based on this exercise, Hashna is true or false? Anyone?
True.
True.
It is true. Why? Because claim is at Hashna. So Hashna is true. So you write here, Hashna is true. And then the what we call the decision that we have here is a reject Hashna. So means that we have here reject Hashna when Hashna is true. What error that we have? Reject
Type 1
Hashna,
error.
type 1 error. Okay, that's how we identify the error. So the error, identify the error, the question will be like identify the error and then state the reason. State the reason. The reason why you say it is a type 1. So what is error? Then this is your answer. What is the reason? This is your reason. Okay, error, what is the error? And then why we say it is a type 1 error? So this is the reason. So both answer must be in your answer lah. Any questions so far? Any question regarding this chapter, chapter 3? Okay, if not, okay, so if no question, then that's the end of the chapter 3 lah. So the arrows type of error is a long subtopic for chapter 3. Okay, so with that we finish the chapter 3. So we go to the chapter 4. Okay. So chapter 4 is about analysis of variance, or we call it as a Anova. So we have 2 types of Anova that we discuss in this chapter. We have the one-way Anova and also two-way Anova. Okay. So in general, we use this method when we compare more than 2 populations. And also, for example, for the two-way Anova, we have 2 independent variables. Okay, the factor are the independent variables. Okay. So one way ANOVA, we have independent variables and also the dependent variable. The variable that we identified before, it is dependent variable. Okay, the data that being collected, it is a dependent variable. Okay. So we have four we call subtopic for this chapter. So we have the introduction to the ANOVA, we have the one-way ANOVA, two-way ANOVA, and ANOVA using Microsoft Excel. Okay, ANOVA using Microsoft Excel means that it will be, you can use the p-value approach letter. Okay, because you are given p-value when we use the Microsoft Excel. Okay, for your information, we have more than these two type of ANOVA. Okay, other than these two, we also have the MANOVA, that one for the multivariate. Okay, just for your information. Okay. So we have two what we call the objective here. So one way ANOVA technique is used to determine if there is a significant difference among three or more means when sample size are equal or unequal. So basically one way ANOVA, okay, we use to compare population mean for more than two populations, so 3 and above. Okay, if you have 1 and 2, then go back to the chapter 3. Okay, and the second one, use the two-way ANOVA technique to determine if there is an effect of interaction between two factors in an experiment. So one-way ANOVA here, we have one factor, and two-way ANOVA here, we have two factor. So when we have the two factor, then we tend to see the interaction between those two factor on the data that we collect. Okay. Okay. Introduction to the ANOVA. Okay, the purpose you can read by your own. Okay, to compare the difference of more than two population means. Okay, even though we compare the mean, but actually we calculate we comparing the variance. Okay, so that's why for your ANOVA we have the F-test. Okay, we use the F distribution. Okay, so one way ANOVA only involve one factor, that is to test the equality of three or more population means, and two-way ANOVA involve two factors, that is to test the interaction effect between two factors. Okay. Okay, so the procedure. So Anova task, okay, Anova method here. So because of we are comparing the population mean, so automatically it is a hypothesis testing. Okay, so this is another method for the, method that we can use to perform the hypothesis testing. With condition, we have more than two population. Okay, so the first step is to formulate the hypothesis. Okay, so doesn't matter what question that you have. Okay, we have similar hypothesis. Okay, the difference is the number of population that you have. Okay, and then step 2, because of ANOVA test, then step 2 is to construct the ANOVA table in order to get the F-test. This F-test, it is not the F-test that we calculate in chapter 3. It is different formula. Okay, in order to get this F-test, you have to construct the ANOVA table because F-test come from the ANOVA table. Okay, and step 3, critical value. Okay, whenever we have the ANOVA, it will be always right t-test. Okay, doesn't matter what hypothesis that you have, it will be always right t-test. Okay. So always right t-test. It is something to do with the F distribution. Okay, so always right t-test, then you will have F alpha, nu1, nu2. So after this, we will discuss what is nu1 and nu2. Okay, so step 4, decision based on the right t-test. Okay, whenever F-test greater than critical value, then reject rational. Okay, and step 5, write the conclusion. We discuss what happened to the claim. Okay. So we go to the one-way ANOVA first. Okay, determine if there is a significant difference among 3 or more population means when the sample size are equal or unequal using one-way ANOVA. Okay. Okay. So what we call the characteristic about the one-way ANOVA, we have one factor. So your factor is an independent variable. So let's say similar lah what we do in chapter 3. Let's say that we have method A, we have method B, and we have, so now before this we have A and B or just A. So now we have more than that, more than 2. So let's say that we have method C. Okay, so the type of method here, this is the factor or independent variable. The one that we always identify in chapter 2 and 3, it is a dependent variable, the data here. What kind of data that been collected? Let's say that time taken to use the method. So that's your dependent variable. Let's say here is a time taken to complete the task using method, using different methods. So this is your dependent variable. Okay, so then, and then we have more than 2 population, then we use one-way ANOVA. Okay. So this is the assumption of the one-way ANOVA, the condition of your data. Okay. In the condition of your data in order for us to use the one-way method. Okay, you can read by your own this one. Okay. The rules that should be fulfilled, but we assume they already fulfilled for the study learning. Okay, model we go when we discuss the exercise. Okay, hypothesis testing, hypothesis. Okay. We discuss the hypothesis after this one, okay, but it should be you already watched the video, okay. So this is the one-way ANOVA table. I don't think that we need to discuss how to calculate this, okay. You can watch the video step by step, okay. But the first thing that you have to know, the value here must not be negative. All must be positive value. So cannot be negative value. If you get negative, be panic and then recalculate. Okay, whatever it is, the whole, the whole value in this ANOVA table must be positive. Okay, kalau dapat negative, please recalculate again until you get positive value. Okay, the ANOVA table here, for me it is easy to get the mark. Okay, why? I will show you how do I mark your ANOVA. When you calculate the SS treatment here, you will get 2 marks. One for the method and another one for the correct answer. And then you have the SSE here, just 1 mark because simple formula. And then total here is a M1 and 1, another 2 marks. Okay, the whole degree of freedom, just 1 mark. And then we have 1 mark here, 1 mark here, 1 mark here. Okay, let's say that you made a mistake on your calculation. Okay, you get different SS treatment, so only 1 mark you get lah. There is no A1. Okay, there is no A1. And then automatically here we will get wrong lah. So A0 and here only 1 mark for example. Okay, as long as the value that you get here positive, the next one you will get mark. Okay, as long as, so here actually wrong value lah, and here also wrong, and here also wrong. So basically incorrect value, but as long as positive value, you will get mark here if you use a correct formula to find the MS treatment, and then you will get a mark here as long as you use the correct formula to get the MSE, and also another mark here as long as you use a correct formula to get the F plus. But everything must be positive. Okay, that's why I said if you have got negative, please recalculate until you get positive value, so that at least you can secure this mark lah. Okay, and then so the critical value, okay, the critical value, so we know that it always be right theta. So you have F alpha, no 1, no 2. So no 1, K minus 1 treatment, and no 2, capital N minus K. Okay, capital N is a total number of your data. Okay, I will wrote here, capital N here, total number of data, and K here, number of treatment. Okay. Any questions so far before we go to the exercise? Any question? Tak ada? Okay. So, okay, so you should watch the video first because all the calculation you can just refer to the video lah. Okay, so what we do here just a summarization. Okay, so we go to the exercise 4.2, the number 2 here. Okay, a consumer group wants to compare a new brand of wax X-Glow to the two leading brands, Sunglow and Microshine, in terms of effectiveness of the wax. Okay, sample from each brand of wax are collected and the data is given below. Okay, once you have this kind of data, here you can see that you have 3 different types. Okay, automatically it is not something from chapter 3. Okay, so chapter 3, it is only 1 population and 2 population. Okay, if we talk about the brand, so must be single brand or 2 brands only. Okay, but here we have 3 brands, so automatically not from chapter 3. Okay, and then we have the data here. So what we have here is a qualitative data lah. For the ANOVA, we have the qualitative data. Okay. Okay, so you can write here. You can, you can identify what is your K, what is your capital N, N1, N2, N3. So the Sunglow here, that's your K1, and not the K, sorry. Okay, this is I equal to 1, this is I equal to 2, and this is I equal to 3, where I represent the number of treatment. So K equal to 3, 1, 2, 3. Okay, so what we have here, the data here, okay, other than we call it as a number of data, it is a replication actually. Okay, replication. So replication denoted by J. So here we have J1, J2, sorry, not here. Should be here. J1, J2, J3, and J4. Okay, so I and J here, it is not the common one when we discuss row and column. Okay, the normal one, I always row, J always column. But here, I and J refer, it can be interchange. Okay, because I will be always represent treatment and J will be always represent replication. The number 1 here, we have I here. This is your I treatment. So I1, I2, and I3. But here we have row as our I. Okay, J as our column. So J replication. Then you will have here N1, 1, 2, 3, 3, and 2. Ya ke? Terbalik. K equal to 3. Okay, so then you can identify here N1, 1, 2, 3, 4 for data, N2, 1, 2, 3, and then N3 you have 1, 2, 3, 4. So 4 data. Okay, so blank here means nothing. Do not fill up with any data. Even though you put 0, it is a data. Okay, so do not fill up with any data. So blank means nothing. So what we have here, unequal sample size. Okay, unequal sample size. Okay, so the A, write down the model, assumptions and rule for constructing ANOVA of the data above. Okay, so the ANOVA here we have single factor, then it is a one-way ANOVA. Okay, so assumptions and rule you can refer to the notes. The model here must be right based on the question. Okay, so model Xij. So Xij represent each of these data. Okay, I represent treatment, J represent replication. Okay, so we have total mean mu plus treatment effect alpha I plus the epsilon ij. Epsilon is an error, random error. And then we have to notify where I represent from. So I represent the K. So we know that K equal to 3. So 1, 2, 3. And J represent the N. So here we have unequal sample size. We have N1 equal to 4, N2 equal to 3, and N3 equal to 4. Okay. So the J here, we have to write until the largest N that we have. So we have 1, 2, 3, 4. So it will cover all the data that we have lah. Okay, so it is until the largest N for the case of unequal sample size. Any questions so far? Soalan?
No idea.
Okay. So from N1, N2, N3, there you can get the capital N. So capital N is a number of data. So 4, 3, 4, you have 11 data. Okay, so this is the what we call notation that you have to know lah. Okay, and based on this, K equal to 3. So number of treatment. So independent variable. What is independent here? What is independent?
Brand of what?
Brand of wax. Dependent?
Effectiveness.
Effectiveness of the what? Okay, the data that being collected here is the effectiveness of what? Identify the treatment in this study and its replication. Identify the treatment. What are your treatments? How we answer this question? Identify the treatment. Is it correct if we write K equal to 3? How to answer? Identify the treatments. Okay, identify the treatment means that we list all the treatments that we have. Okay, Sanglo, Microshine, and S-Glow. And each replication. Each replication, as I said, replication here is a number of data that we have for each treatment, the N. So how we write this question, this answer for the C? Okay, you will have the Sanglo, okay, Microshine, and then S-Glow. Its replication Sanglo we have 4, Markoshan we have 3, and Sglo we have 4. Okay, that's how we answer this question. Okay. Is there any variation in means among the rank of rats in comparing the effectiveness of rat at 0.1% significant level? Is there any variation in means? The keyword here, any variation in means. So variation means different in means. So different in mean among the brands of rat. So the brand here we have, so the keyword here we have first different in mean. And then the brand here we have 3 brands. So definitely it is not method that from chapter 3. Okay, we cannot use method from chapter 3 because of 3 brands here. Okay, so it is one way Anova. Okay. So the first step, hypothesis. Okay, so it doesn't matter what question that you have. We have similar type of hypothesis. Okay, so by notation, okay, we can have here Hashna. So we have K equal to 3. So we have mu1 equal to the mu2 equal to the mu3. Okay, so mu I not equal to the mu j4 at least 1 I not equal to j. Okay, so for at least 1 I not equal to j, compulsory to write. Okay, you tak ada this statement, salah this hypothesis. Why? Okay, in order for us, okay, mu I, mu j, it is a combination of your treatment here. So means that what we have here, it is a mu1, mu2, mu1, mu3, mu2, mu3. This is what we have actually. Okay, so in order for us to reject the Hashna, we just need one combination is not equal. Then we have to reject the Hashna. It is not necessary, or we do not wait to all the combination it is not equal. Then we reject the Hashna. At least one combination is not equal, then we have to reject the Hashna. That's why we have at least one here. Okay, without at least one, salah that hypothesis. Okay, or you can write in terms of sentence your hypothesis here. So both will be accepted. Hashna, all the population means are equal. H1, you need to mention the at least one here. So at least one of population mean is not equal. Also correct lah. It's up to you. You can write in terms of notation or you can write in terms of sentence. Any questions so far? Okay, so step 3 is an Anova table. Okay, so you can read by your own here. What do you get for your task if you already done? What do you get for your task? Someone?
2.2238.
2.2.
238.
2.238. That is
2238.
2238. The rest of you, did you get similar as this one? Correct, tak buat lagi. The rest of you get similar? I don't have to. I don't have the book. Tak boleh cakap I don't have the book yet, Amma. You have the slide note that you can use, and also you have the what we call the videos that you can watch. Okay. So some of you got same, so should be same lah. Okay. So for those who still not try this exercise, okay, make sure that you get this after lah. Okay, if you need anything, you can always ask me lah. Okay. So okay, apa yang cakap tak ada module tak apa, you can refer to the slide notes, and also slide note already upload in Kalam, you can get from the Kalam, and also you can watch the videos lah. But if you have the module, then you can refer, you can try the tutorial questions from the module, because we are not provide you with the tutorial questions. So if you just have the slide note, it is only the exercise question lah. Okay. So after you should get this, okay, you can refer to the video, because in that video, the lecturer already explained one by one how to get those value. Okay. So step 3, we find the the critical value. So it is always right theta. Okay. So alpha is 0.1%. So divide by 100, we have 0.001. Okay. No 1 is a k minus 1. No 2 is a capital N minus k. Okay. So you have k minus 1, 3 minus 1, 2, capital N minus k, 11 minus 3. We have 8. What you get?
18.4937.
493. Okay, so 18.4937. Okay, and then step 4 decision. So compare with the afters. So your afters is somewhere here. So decision is reject or do not reject?
Do not reject.
Do not reject. So afters less than critical value. Then do not reject Hashna. Okay, step 5 conclusion. So at alpha 0.001. Okay, do not reject Hashna means that we support the Hashna lah. Okay, it is okay not to write the claim. Okay, what you can write here, paling simple, you can state here all the population mean are equal. Paling simple you can state. When do not reject Hashna. Okay, if you reject Hashna, yang paling simple you can state at least one of the population means is not equal. Okay, or you can answer this question lah. Is there any variation in mean? So do not reject Hashna means that there is no variation in mean. So you can write here. At alpha there is no variation in means. Okay, among the brand of verbs. Yeah, also okay lah. Okay, so it's up to you, the conclusion. Any questions so far? So for those who still didn't do this question, so please try because it will be in your quiz form. 4.2, it is your quiz 4. So I plan quiz 4 after the quiz 3 lah. Okay. So 4.2, it is your quiz 4. Okay. So it is important to have the experience to calculate, to find the ANOVA table. Very important. Okay. Because it look easy, but you will be panic if something wrong. Okay, so please try before we go to the quizzes later. Okay, Okay, so two-way ANOVA is supposed to be next week, but I want to go to the mm, it's okay lah. 4.4 we discuss next week. Any question regarding the one-way ANOVA? I think chapter 4 is the easiest chapter that we have. Okay, because a lot of the calculation but simple. Okay, a lot of calculation but simple. Okay, just a simple calculation, and then we have like a single formula for that. Okay, so it is not I mean simple lah, simple. So we should score for the chapter 4. Okay, the quiz 4 letter it is about 4.2, so you should score that quiz lah. Okay, just a simple one, a lot of the calculation but simple calculation. Any question? And also if you start from the scratch the ANOVA table, it is a lot of marks. At least you can secure that marks, okay, the mark for the ANOVA table. So that's why before we go to the quiz 4 letter, make sure to practice first how to calculate the ANOVA table. Make sure that you have the experience to calculate the ANOVA table. Okay, any question for today? No?
No, madam.
Okay, so insyaAllah later today I will upload your test, okay, the mark for the test, and hope that you are happy with that mark. Okay, so don't forget the quiz 3 next week. It is 3.3 only. Okay, independent samples and also dependent sample. Okay, so that's all for today. Thank you class, see you next week insyaAllah.
Ada attendance ke?
Attendance nantilah saya buat dalam Google Classroom.
Okay.
Okay. Thank you class.
Thank you, madam.
Thank you, doctor.
Thank you, madam.